If you could turn the request, "I need a new app in production," into a well-architected Terraform deployment in just a few minutes, wouldn't you want to see how? In this video, I'm going to show you how agents, which are currently in preview in Azure Copilot, can act like your virtual cloud solution architect and how it actually applies the Azure Well-Architected Framework as it designs and scaffolds your infrastructure. Let's talk Azure Copilot's deployment capabilities and the Azure Well-Architected Framework in this MS Cloud Bros video. Hey guys, this is Jeremy Wallace, Microsoft MVP, certified trainer, and solutions architect for Azure. I just got access to the new agents preview in Azure Copilot, and this is part one of a series where we walk through each type of agent. Today we're zeroing in on the deployment capabilities, how they help you ship a well-architected workload without starting from a blank whiteboard. In a minute, I'll walk you through what the deployment agent does and where it fits in with your architecture practice, and then we'll jump straight into a live demo in the Azure portal where we go from a plain English goal to a well-architected Terraform deployment for a simple web app and database. But first, take a moment to like this video, subscribe to this channel, and hit that notification bell so you can stay up to date on all our great Microsoft Cloud content. All right, what the deployment agent actually does. We'll hit the Azure portal here shortly, but let's start with the mental model. When you enable agent mode in Azure Copilot and ask it to help you deploy something, you're not just getting a blob of code back. You're engaging a deployment agent that behaves like a virtual cloud solution architect. It does three things. First, it translates high-level goals into actionable deployment plans instead of saying, create a resource group, and then an app service plan, and then a web app. You just say something like, I need a production-ready, scalable web app with a SQL database and monitoring. The agent takes that goal and turns it into a structured plan. Second, it anchors that plan in the Azure Well-Architected Framework as it builds the workload plan. It's applying best practices across the well-architected pillars: reliability, security, cost optimization, operational excellence, and performance efficiency. You're not manually cross-checking every choice against a PDF. The agent is doing the alignment for you. Third, it supports multi-turn conversation. It doesn't assume it has all the answers. If it needs more detail, regions, scale targets, availability needs, it asks. You can iterate, make this multi-region, or optimize for cost performance, and it will refine the design. So think of it like this. You bring the business and technical intent, and the deployment agent brings a well-architected, Terraform-backed deployment plan. All right, let's jump into the Azure portal. All right, I'm in the Azure portal, and here at the top bar, I'm going to hit the Copilot icon. That's going to bring me into Copilot, and I'm just going to full screen this because we have that nice full screen capability now here. And down at the bottom here in the Copilot pane, I'm going to enable agent mode by hitting this, toggling this button here. That tells Copilot to use the specialized agents, and in this case, we want the deployment agent. So I'll describe the workload in plain English, and here's the prompt that I'm going to use. I want a production-ready, scalable web application with a SQL database. Design the architecture using Azure App Service for the web app, and Azure SQL Database backend, and the application insights for monitoring, and apply the Azure Well-Architected Framework for best practices, and then generate Terraform configurations for this environment. So I'm going to go ahead and run that. So notice what I didn't do here. I didn't specify SKUs. I didn't define subnets. I didn't write any Terraform. I just described the intent and called out what I wanted it, that I wanted it aligned with the Azure Well-Architected Framework. So we'll let the agent do its thing, its reasoning. And the last thing now is we do have the activity, so you can show the activity and kind of follow along with its reasoning as it goes along. So we'll give that a moment. All right, so it's completed its work. So if we kind of walk through what it did here. So it's starting to generate the plan and break that down. Searching for a pre-built template for web app, SQL app insights. It's checking and doing some research on that. And then collecting Azure Docs and concise guidance on app service, Azure SQL Key Vault, networking, monitoring backups, and well-architected best practices. So from that, it's generating the artifact Azure infrastructure plan file. And so now if we dive down in here, we can see what it's produced. And let me full screen this here. So we can see this plan provisions a production-facing app service hosted web app, Premium v3, Azure SQL single database, general purpose vCore, centralized application insights backed by log analytics, Key Vault, and private endpoint, VNet and private endpoints for SQL and Key Vault, managed identity for least privilege access, diagnostic settings, and foundational monitoring, alerting, and backup strategy. Design choices emphasize secure by default networking, managed identities over secrets, autoscale and resilience, and centralized observability per the Azure Well-Architected Framework. While adding features may incur charges, this is not a deployment and no changes will be made to your infrastructure right now. And scale headroom, teams can start with smaller SKUs for POC and expand after capacity tests. So it goes over the Azure Well-Architected Framework principles that are built into the plan. So the secure by default, operational observability, managed identity first, autoscale performance, resiliency, and recovery. And it even links to the well-architected framework practices that it looked at. And then we can see its resource strategy. RG Web Prod, VNet Prod, Log Analytics Prod. So it's spelling out everything here, where all the pieces are and what it's going to work with. And then we can take a look at the additional resources of things that it's referenced. So with this plan in place, it ends with continue on. If this plan looks good to you, you can deploy or get scripts in the next step, or see plan details for specs, process, and alternatives. So I'm going to go ahead and just hit the quick button for I approve the plan. Let it continue on and do its thing. Once again, we can see it reasoning through. So now it's generating the Terraform for approved app service SQL and app insights plan. And we can see it begin to generate the Terraform configuration. We do see it doing a round of fixing Terraform configurations, validating and fixing and repeating that process. All right, we can see here the Terraform configuration for your approved infrastructure plan, which includes Azure App Service, SQL Database, and Application Insights, have been successfully generated. These configurations are now ready for deployment. If you need to review or make any edits, feel free to let me know. So you can, again, review this information. And if you need to make any adjustments, you can tell it. So if we take a look a little closer to, we can even open in VS Code Web. So we can see it launches VS Code for the web workspace with all the generated Terraform files already preloaded. So no local install, no bootstrap. Now it just feels like any other Terraform repo. I can refactor, I can add modules, enforce my team standards, all while staying aligned with the plan the agent created. All right, so also back on the artifact plan, I have the option to create a pull request, which I'm not going to do right now. But here I can sign into GitHub, pick a repository and branch, and let Azure Copilot create a PR with those Terraform files. And that means I can drop this straight into my existing GitOps or CI/CD pipelines, code review, approvals, automated deployments without changing how my team ships. So in just a couple of minutes, we've gone from I need a production-ready web app and database to a well-architected deployment plan and Terraform wired into VS Code Web and optionally into GitHub via a pull request. So if I were to deploy this, I'd go into, of course, VS Code. I already have that open here. And then I just want to verify I'm in the right workspace. I see my Terraform files that are here that were produced by the Copilot agent. And so I'm just going to open up a terminal. And you can use the command show account to show what Azure subscription you're currently connected in. In my particular case, I have already set that, and I don't want to expose what all my Azure subscriptions are. If you have multiple Azure subscriptions in your tenant and you need to define the specific Azure subscription you want to deploy to, you can use AZ account set and then subscription, and then I just put the name of the subscription and it'll set that as the context in which you are doing stuff. So if you have nothing already in the Azure environment for the Terraform state to live in, which I don't in this particular case, then you're probably going to want to lay down a storage account for that. So I'm going to set a few variables here and set a resource group. Let's do rj state. And we'll do location is East US. And we'll do the storage account name is going to be TF state. Let's just do TF state, Azure Copilot, demo, east US. All right, so with that, I'm going to do AZ group create, and we'll do that resource group. And the location is going to be the location variable that we set. All right, so that creates my RGTF state resource group and my East US location. And then I'm going to create the actual storage account in it. So I'll do AZ storage account create. The name of that is going to be in my SA variable. The resource group I'm going to use for that is, of course, RG. And then that's going to be in that same location. So we'll use loc. And the SKU, let's just do standard LRS for that. There. So what was going on is I hadn't registered the storage account provider inside this subscription. So I just had to run AZ provider, register the storage provider, and then now it allows me to create the storage account. Then I'm going to grab the AZ storage account key list inside the key variable. And then I'm going to go ahead and run AZ storage container create. And then I'm going to use the name of that container that we defined earlier. Under the account, account name, the storage account name variable. I'll grab the account key from the key variable. Oops, did I spell? Wow, I'm messing up all sorts of things. There we go. All right, and then with that created, I'm actually going to add a backend TF here. For this, I'm actually going to put the name of my storage account, which is here. And then real quick, I'm just going to run Terraform init. I'm going to reconfigure. Oh, that's right. I had changed the format of this. So this should be RG. Let's try that again. Let's validate that. Can't spell. All right. Oops. Must have hit it. All right. Just want to make sure that it stopped having to guess. So I just exported the subscription ID and the tenant ID. That way it knew exactly the context that it was working in. All right. So it compiled the plan and saved the plan to TF plan. All right. So what's left is to run it. Oops. Terraform. Still can't spell. Terraform. Apply. TF plan. Well, that's going to start our deployment. So other than a little bit of manual work that I had to do to initially go create the storage to save our state, which we didn't have to do. We could have ran it as is. It was just better ahead of time to save that state in the storage account. So if we go to our resource groups, now we see we have this RG web prod and these resources being deployed to it, our virtual network, our subnets all built out. And this is all stuff that was planned out and architected by the new Azure Copilot deployment agent. All right, the example I just showed is a simple web app plus database, but the deployment agent isn't limited to that. It can help you design and deploy across compute, networking, storage, identity and access, and monitoring and diagnostics. Before you roll this out across your entire organization, there are a few current limitations you need to be aware of. First, generated artifacts are Terraform only right now. If your team is all in on Bicep or ARM templates, you can still use the plan for design guidance, but the auto-generated artifacts are Terraform. Second, the deployment agent is optimized for greenfield scenarios. It's designed to help you deploy new workloads and environments. It doesn't import, analyze, or directly modify existing infrastructure. You can still ask Copilot questions about your current environment, but the deployment agent itself isn't a refactor my entire production subscription for me button. Third, the CI/CD integration is advisory, not fully automated. The agent will give you guidance on secure deployment pipelines and integrate with GitHub via pull requests, but it doesn't build and configure your whole pipeline end to end for you yet. So use it where it shines. Net new workloads where you want to start well-architected and infrastructure as code from day one. Why this matters. From a practical standpoint, this does a few powerful things for you as an Azure engineer or architect. It reduces the time you spend on repetitive design and scaffolding. Instead of reinventing the same web app plus database pattern for the 100th time, you can let the agent get you 80% of the way there and spend your time on the 20% that's unique. It bakes in the well-architected thinking from the start. You don't have to remember every checklist by heart. The deployment agent is already grounding decisions in the Azure Well-Architected Framework. It lowers the risk of misconfiguration. By generating complete Terraform configs based on a consistent plan, you're less likely to miss critical pieces like monitoring, diagnostics, or secure defaults. And it helps smaller teams scale their architecture capability. You may not have a dedicated cloud solution architect on every project, but with the deployment agent, you effectively have one participating in every new workload conversation. If your tenant already has access to the agent's preview in Azure Copilot, here's what I'd encourage you to do next. Open the Azure portal, click the Copilot icon, enable agent mode, and describe a workload you actually care about. It can be as simple as the web app and SQL example we used today. Let the deployment agent build the plan, review how it aligns to the Azure Well-Architected Framework, and then inspect the Terraform it generates. Open it in VS Code for web, or push it into a GitHub and run it through the normal review process. In the next part of this series, we'll look at other agent capabilities inside Azure Copilot and how they help you not just deploy, but also optimize, operate, and govern your environments through the same well-architected lens. If this was helpful, hit like, subscribe, and drop a comment with the first workload you'd want to try with agents in Azure Copilot.